Hello, hi everyone. Welcome to the Student the Brand. Now we are going to discuss about electricity chapter. Electricity chapter. Okay. So we'll see. So in the previous class, I explained about electricity chapter. Okay. So hi Ayush. So join. Very nice. Good evening. Good evening, ma. So now I am considering electricity chapter. So yesterday I explained about electric current until electric current I explained, right? So now I will explain complete chapter once again. Based on that one, problems we'll discuss. So electric current. So notes also I'll try to give notes. So try to make it as a notes. So note down. I'm considering electric current. Electric current is nothing but the rate of flow of charge. I equal to Q by T. I equal to Q by T. So that is nothing but rate of flow of charge. So flow of charge through unit cross section area per second. Flow of charge through unit cross section area per second is called electric current. So SI unit of current is ampere. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of charge is coulomb. And SI unit of time is second. SI unit of time is second. So this is nothing but a rate of flow of charge. So 1 ampere equal to 1 ampere I am considering. So 1 ampere equal to 1 coulomb per 1 second. 1 coulomb per 1 second. So 1 coulomb is nothing but 1 ampere is nothing but SI unit of current. So 1 ampere is the SI unit of current. So 1 ampere is SI unit of current. 1 coulomb, SI unit of charge is coulomb. SI unit of time is second. SI unit of time is second. So that is nothing but rate of flow of charge. So the flow of charge through unit cross section area per second. The flow of charge through unit cross section area per second is called electric current. So I equal to QT. So 1 ampere equal to 1 coulomb per 1 second. So next one we'll go for electric current charge. So its charge is very important. So charge is a property of the matter. Charge is a property of the matter. Okay. So charge is the property of the matter which can influence the presence of other charges. So if you are considering the conductor, Ayush sir, what is the difference between resistor and resistance? Yatindra, hi. And Ayush, so resistor is a device. So here I am considering resistor is a device which is used to oppose the electric current. Resistance is the phenomenon of the process, whatever process is happening. Okay, so that is called resistance. Resistor is a device. Which is used to oppose the electric current. So Yatindra, hi. Ayush, so I hope you got the answer. So charge is the property of the matter which can influence the presence of other charge. Charge is a property of the matter which can influence the presence of other charge. So here I am considering here electrons, whatever the charge will not flow single. So there are a group or many like that. So integral multiple. So charge will be from moving in the conductor integral multiples. That's why. So Q you are considering plus or minus Ne. Plus or minus Ne why we are taking here. So charge we can take positive charges, negative charge, both will move in the. Oh, thank you, sir. Okay, so positive charge and negative charge both will move inside of the conductor. That's why I'm taking plus or minus Ne. So quantization of charge is nothing but integral multiple. So charges will move integral multiple. Number of charges will move. Number of charges will move inside of the conductor. That's why I'm considering the plus or minus Ne. Plus or minus Ne. So positive we are taking proton. Example proton. And negative if you are considering negative if you are considering electron. Proton is positive charge, negative charge is electron. Proton is a positive charge, negative charge is the electron. Okay, so here in this point, so there are two more points. So positive charge will repel. Positive charge will repel. So positive charge, negative charge will attract. Positive charge, negative charge will attract. Okay, and negative charge, positive charge will attract. So negative will repel. So here also one more point, negative will repel. So these are the points. So actually even in magnetic effects of electric current, so related to this point will come like north pole, south pole, north pole, like that points also we are considering. Here we can take so I'm giving the notes also, try to make it a running notes. Okay, so maximum try to give proper notes, all points will be mentioned, so you can note down all the points. These points will be helpful for exams. At the same time, for solving the problems also we can able to use these notes. So try to write running notes whenever you are not attending the class. Try to take a book and write the running notes. Hi sir, I am new here. So what is your name? Sudarshan. Very good. Welcome to the class. Welcome to the student the brand. So can you tell your name? Anaswara Sudarshan. That is your name? Okay, fine. My name is Anaswara. Okay, very good. So Anaswara, so nice. So you can take here. So you can consider all the points. I'm giving everyday notes. Okay. So try to write down notes. So one more student is need to join. So Shivani. Shivani still didn't join. So Shivani, I'm waiting. So if you are there in the class, just say hi. Okay. So like attendance. As I'm saying. So in the school we can take, in the college we can take. Now here, so like Anuswara, I'm new, like that, introducing yourself. So then I can take class. So okay, done. So come to the point. So electric current. Once again, I will explain. Oh, Shivani, very good. Yeah, that's why I'm waiting. So whether you joined or not, very nice. And Aishu is immediately, when I was starting the class, immediately joined. Yeah, present attendance is marked. And one more, Tanishka. Tanishka, are you there in the class? Tanishka also new student. I mean, sorry, new joinee. Recently only she joined. Okay, done. Fine. Come to the point. So we'll explain. Anaswara, so try to make a notes. So I'm giving each and every point in detail. So try to make a notes. You can get it. So electric current is nothing but I equal to Q by T. So electric current is nothing but I equal to Q by T. So current is the SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. So Aish, your attendance is marked automatically. Okay. So here charge is quantization of charge Q equal to plus or minus Ne. So Q equal to plus or minus Ne. So because it's a quantization of charge, so charges will move inside of the conductor. So like many it won't move one or two like that. So number of integral multiple. So integral multiple like charges will move. That's why we are taking this one. So Q equal to Ne. So this we will use based on this one. Problems will come. So positive charge proton, negative charge is electron. So positive will repel, positive negative will attract, negative will repel. So right, shall I? Okay, done. So next one, shall I rub it or I have to wait? Let me know. So shall I rub or go to the next topic or I have to wait? So those who are there in the class, you can continue. Let's go. Okay. Okay, done. So next one. I here based on this only I am going to explain. That is nothing but I equal to Q by T. So I equal to Q by T I am explaining. That is. So here you can see. Here I am considering like this. So based on that one problems they will ask. We will solve few problems related to that questions. I equal to Q by T. So I equal to Q by T. So Q is nothing but NE by T. NE by T is nothing. Overall you can take I equal to so NE by T. So NE by T. So here one point is there. So this formula is very very important. Make sure that nice class. Abel George. So in the previous videos you mentioned, right? So you said you commented also. I do. You didn't say your name. Your name? Abel A. George. Your name? Okay, fine. So fine, no problem. So you can go to. Thank you so much. So here I equal to Q by T, Ne by T. So I equal to Ne by T. So here we are considering. So electron, if you are considering, so charge on electron is 1.6 into 10 power minus 19 coulomb. So this value is very very important. Make sure that you have to. So remember this one. If it is electron, negative sign we have to take. If it is proton, positive sign we have to consider. So 1.6 into 10 power minus 19. So generally we will take the magnitude only. So we will consider the magnitude only whenever we are substituting. So note down these points. So here see I equal to Q by T, Ne by T, I equal to Ne by T. So that is nothing but so charge on an electron. Charge of an electron is 1.6 into 10 power minus 19 coulomb. So positive charge if you take, negative charge I am considering now. So that's enough. So very very important point. Based on this one, so problems will come. One more point is there. In 1 coulomb, how many electrons are present? In 1 coulomb, and 1 electron, how much charge is present? So this is the value. On 1 electron, how much charge is present? In 1 coulomb, how many electrons are present? So that is nothing but 6.25 into 10 power 18. 10 power 18 electrons. So 6.25 into 10 power 18 electrons. So in 1 coulomb, how many electrons are present means 6.25 into 10 power 18. How you got this also I will explain. How you got this value also I will explain. So very very important question will come based on this one. Very very important question will come. So that is 2 marks may come, 1 mark may come. So these values they will ask in the exam. I equal to Q by T, Ne by T, I equal to Ne by T. So here, so related to this one, generally we follow this formula. So I equal to Q by T, the rate of flow of charge, I equal to Q by T. Sir, is the charge of coulomb constant? Charge of coulomb. Yeah, this value is constant only. Less than this value does not exist. Less than this value does not exist. Yes, less than this value does not exist. Only this value only it will be. So there is one question. So charge. There is one question is there. So I will tell this one. Actually, I have written these questions also. Yes. How much is the charge of an electron? So this is the question. How much is the charge of an electron? Can a charge less than this value exist? No. The charge of an electron is 1.6 into 10 power minus 19 coulomb. So 1.6 into 10 power minus 19 coulomb. Okay, so I am writing few more questions including marks also. I am writing. Okay, so this is the question. How much is the charge of an electron? Can a charge less than this value exist? No, less than this value does not exist. Okay, so 1.6 into 10 power minus 19 coulomb. 1.6 into 10 power minus 19 coulomb. So, Abel, your name? If it is okay, you can say. Otherwise, I'll call on that name only, because you are attending the class and taking notes. If any concern, any doubts are there, so you can comment. I will respond to that comment. Clear? Okay, done. So come to the point. So this value 6.25 to 10 power 18 electrons. So these 2 points are very, very important. Make sure that, so remembering these 2 points, very, very important. And the values also in MCQ's point of view, these values are very important. So related to formulas also, and here related to this, this formula, related to this formula, how you get this value also, how you will get this value also, I will explain now. How you will get this value also I will explain. Shall I rub? If it is okay means I will. So I'm erasing. If any concern is there, let me know. Okay, done. So here, from this all I am considering, in 1 ampere of current, how many electrons are present? In 1 ampere of current, 1 ampere of current. So 1 ampere of current is flowing through unit cross-sectional area. How many electrons are present? So there are many questions. Different way they will ask. Only single question. So they can ask in many ways. Okay, in 1 ampere of current, how many electrons will flow? How many electrons will flow? So that question also there. So I'll check it once. Here I am considering. Okay, it's fine. The charge possessed by an electron is, yes, this is the question. So the charge possessed by an electron is, so here you can see this is the question. I hope 26th question. 26. Here. Check once. I hope it is visible to you. 26th one. So you can read the question, or you can take screenshot. The charge possessed by an electron is 1.6 into 10 power minus 19 coulomb. Find the number of electrons that wire flows per second to constitute a current of 1 ampere. Okay, so this is the question. So here you can see. First one is on 1 electron. So 1 electron I am taking, and 1 electron I am considering here. 1 electron. So 1 electron, 1.6 into 10 power minus 19 coulomb. 10 power minus 19 coulomb. So time is 1 second. Time is 1 second. And current is I equal to 1 ampere. I equal to 1 ampere. So we need to find out number of electrons. So number of electrons. What formula we have to use? So this is the question. What formula we have to use to find the number of electrons? So this is the question. So electron charge given, that is nothing but E. So T is given, I is given. So what formula we can use? I equal to Q by T. So this is basic formula, that is nothing but Ne by T. So I equal to, so N is nothing but, so we have to find out. So here you can substitute directly. So that is nothing but 1 equal to, so N into 1.6 into 10 power minus 19. 10 power minus 19. So 1 equal to N into 1.6 into 10 power minus 19 coulomb. So we can take a time. So 1. Now if you are taking N equal to 1 by 1.6 into 10 power minus 19 coulomb. So 1 by 1.6 into 10 power minus 19 coulomb. So now if you solve 1 by 1.6 into 10 power 19. So 1 by 1.6. If you solve this one, so if you solve this value, you'll get. So try to solve it. This question. 1 by 1.6. So if you want to solve 10 by 10, you can multiply. So those who want to solve in easy way, so you can take 1 by 1.6 into 10 by 10. Then you will get a 10 by 16. So 10 by 16. Then you will get a 0.10 means, so the denominator value is greater than numerator value. denominator value is greater than the numerator value. So that's why 0 point we have to take. So 0 point 100 we will get. How many times it will go? 6 and 2, 5 until like that. So here 0 0.625 you will get. So here I am considering. Try to solve it. So 0 0.625 into 10 power 19. So 10 power 19. We are removing the 1 0. So we are removing the 1 0 and try to solve 6.25 into 10 power 18 electron. 10 power 18 electrons, because it's a number, right? So number we are asking. So there is a number. So 6.25 into 10 power. Sir, you can go. Always fine. So here you can see 6.25 into 10 power 18 electrons. So this is the value. So like this we have to solve the problem. Sometimes they will ask for 3 marks also. So this question they will ask for 3 marks. Yes, you can see it is 3 marks question, this one. 26. Here a marks also I have written. You can observe. I wrote marks also. 3 marks question, that one. Clear? So that's enough. That is about consent. This is the problem. This is very, very important. So and here this question they asked in many ways, not only this one. So one more way also they can ask same question only, no change. So you can note down if you want. You can note. So very, very important. Meanwhile, I'll check. You can note down. So many problems are there. So we'll do it. The problems. I wrote problems from electricity. So as of now, I have written 64 questions. So I wrote 64 questions. As of now, I wrote 64 questions. So still it is continuing. We'll see. Okay. So we'll work out on 64 questions. These are the questions. Apart 100 problems. Apart 100 problems, there are 64 questions are there. So apart 2 books, 100 problems are there. Apart those, so theory and problems are there. Those we will do it. Okay. So try to attend the class regularly. So this electricity we will work out like a war. Okay, we will do war. Okay, on the electricity chapter. Okay, so at any cost, whatever we do, we have to work out. Okay, we have to work out. We have to get it. Okay. So whether you hard work or whatever you do, so once you involve, so you must get it. So actually related to graph potential difference and current, that is related to Ohm's law. So those questions also will do it. Graphical questions, the related to Ohm's law. So definitely will work out. Surely each and every point. See, there are number of models are there. So I am trying to cover all the models. We'll work out on all the models. Okay, Shivani. Surely we will work out in 9 o'clock class. So definitely all the models I'll cover. So day by day, when concept plus problems, I'm trying to trying to do concept plus problems. So we'll see, because based on the concept, if you do problems, your concept will be getting stronger. Automatically, you can remember well, right? So next one. So we're going to the convention. So based on this one, based on electric current, that is nothing but I equal to Q by T. So this is the formula, and still a few more questions are there. Sometimes they will give number of electrons, current they will give, and time they will give. We have to find out E value. Sometimes N value, E value, T value will give. They will ask the current. So like that, number of ways. Sometimes they will give N, E value, T value. We have to find out current. Sometimes they will give N, E, I. So we have to find out T. Sometimes they will ask. So this question, E value, T value, I value. See, E value we have to remember. As I said, E value, Hello, sir. I have exams of my science on next Monday. So, 80. Then they please teach science on Saturday or Sunday. Uh, Ahmad Anhad. Anhad, right? So, can you tell your name? Actually, completely I will dedicate it, my time to physics. So if you have any doubts in physics, three or four chapters: light reflection and diffraction, human and colorful world, electricity, magnetic effects of electric current. If you have any doubts, yes sir, it is Anhad. Very good, Anhad. I dedicated my whole heart, so it is too much word, but still we have to use. I dedicated my whole heart to physics, so I am using. Okay, so my time for physics. So physics I can teach. If you have any doubts, definitely I will clarify. Try to ask more doubts in physics. So I'm ready to teach. Science is nothing but biology and chemistry also will come. Uh, yes, light chapter is coming to my exam. 100%. So you join to the class. Uh, Night is, so we are going through the electricity. So if it is possible, you can join to the 6 o'clock class. 6 o'clock class also I am trying to explain light chapter. Okay, light chapter, everybody one chapter. 6 o'clock time. So evening 6 o'clock I am explaining remaining chapter, human eye, light chapter and magnetic effects of electric current. Daily I am trying to complete at 6 o'clock. So 9 o'clock class I'm dedicate. So I dedicated this time for electricity because we need to work out more on electricity. That's why I dedicated this time for electricity. So sure, I will explain light chapter. I will explain light chapter. Okay. So at the end, at least after completion of one a few concept, few problems. At end, I will explain. So try to join. So Saturday, Sunday, right? Okay. So remember me. Okay. Give a reminder. Give a reminder to me. So definitely, I will explain light chapter. Okay. Okay, sir. Tomorrow is my English exam. Okay, okay. Sure, Anhar. So give a reminder. So definitely I will explain light chapter. So no doubt at all. In physics, if you ask any chapter, I am ready to explain immediately on the spot. Now, if you want to explain, if you ask me to explain four chapter also, I am ready to explain. So each and every point in detail. So including problems. Okay, so I'm ready. Now we are going with the electricity because so we are no working so hard to uh, finish the electricity chapter. Done? Yes. So come to the point. Now I am going through this one. So electricity. So I equal to Q by T. So that's enough. Based on this one, this type of problems will come. So next we are going with the one more concept. Conventional electrical appliances I will explain. So based on that one, so many concepts are interlinked. So electrical appliances, electrical appliances. Those are electrical appliances, electrical components. We can say components or electrical appliances. So electrical appliances is a scientific word. Okay, so we'll use that one only. Electrical appliances. So now you can see. So this is the cell. So positive terminal, negative terminal. Next one, battery. Battery. Next one, switch. Open switch. If dot is there, that is yes, Shivani. How do you know that? Have you got it? So I didn't speak in the class also, right? Okay, maybe because of my slang you identify. So here, first one, open switch, closed switch, open switch and closed switch. And next one we are going to the so rheostat, resistor and rheostat. Yeah, actually, sir, you uploaded Telugu motivational videos and also said you are in Hyderabad. Yeah, of course, correct. Yeah, I upload this. So even I can teach in Telugu also. So I can teach Telugu in Telugu also the concept. Okay, that I will start. Now I'm going with the English language, so English channel. So I'm working on it. So then if it is possible, I'll teach in Telugu also that concepts. If it is required, if it is in demand, then if they're asking, students are asking to teach, then I will work out on it. So here resistor, this is the resistor, rheostat, rheostat, rheostat. Next one ammeter, ammeter, ammeter. So positive terminal, negative terminal. So voltmeter, voltmeter. Next one. So here we can take bulb, bulb, bulb. So wire joining, wire crossing. So these are the points. So you can see now, here I am taking the cell, this is the cell, battery, open switch, closed switch, resistor, rheostat, ammeter, voltmeter, bulb, wire joining, wire crossing. So actually based on this one question will come. Based on this one question will come. How they will ask? So I'll tell how they will ask the questions related to based on this here. What does the following circuit symbol represent? So here this is the question. So you can see. Okay, Sevani, no problem. So I won't teach now right now. So it's going to English only. So here you can see this is the 45th question. 45th question you can see. 45th question. 45th question. The question is related. What does the following circuit symbols represent? What even you can play back this live class. You can watch this one. So fine. So here they are asking what does the following circuit symbols represent? First one is wire crossing. Second one is rheostat. Third one is resistor. So one mark. This is 3 marks question. This is for 3 marks. Simple. See, CBSE people, if they want to touch your basics, so how good you are at the basics, how you are preparing, whether you went to the basics or not. So if they want to touch the students' basic knowledge, definitely this type of questions they will ask. Generally, in the chapter, so we will prepare so much theory, problems. Actually, from total 12 marks. Okay. So here it may 6 marks, magnet effects of electric current, 6 marks, like that it will come. Okay. So 3 marks. MCQs also there, right? MCQs also will come. 5 marks. 5 marks MCQs only will come. And assessment reasoning, straight objective type questions, like that. Okay. So now we are working on it. Electricity mainly they'll focus on activity based questions also. There is a possibility to give activity based questions also. Activities also I'll explain. So meanwhile we are working now. So can I continue? Yes. So these are the symbols, electrical appliances. Now we are going to the next one. Conventional current and electric current. So here generally people will get confused, sir, what is a conventional current, what is electric current. So in the textbook, in the first page, last 4 lines you can read. In the textbook, electricity chapter, first page, you can check. So I don't have CBSE textbook right now to show. You can check CBSE textbook, grade 10 physics, first page, last 3-4 lines. 3-4 lines, they will explain about last 3-4 lines. They will explain about conventional current and electric current. Those who are checking, you can let me know whether it is correct or not. So it will be correct because so that answer is there from that only. Okay. So conventional current and electric current. Conventional current is nothing but before. Yes, ma. Actually, some of the topics, actually, in magnetic effects of electric current, they removed the topics. So, like motor generator topics, they removed, and electromagnetic induction topics also removed. Actually, those topics are important for JE and NEET students. JE and NEET students, if it is required, at the end I will cover those topics. At the end, I will cover those topics. But in electricity, these topics are there. So whatever the topics we are discussing, those topics are there. We will continue with those topics. So remote topics we will discuss later. So if it is possible, if it is time supports. Okay, first we need to here on magnetic effects of electric current only. In that only it is removed. So they won't ask about completely generator and electromagnetic induction. Yes, I am covering those topics only. Recent topics only I am covering. So we are working on it only. So those topics only we will cover. Check. Latest updated according to latest updated book only I am discussing. So now we can go for a conventional current and electric current. Conventional current and electric current. So conventional current, conventional current, conventional current first one, and the second one is electric current. Electric current. Okay, conventional current is nothing but normally electrical current we discuss. Now electric circuit. Here. So I'm taking the circuit here. So ammeter. So bulb. So here if the current is passing like this, current is passing, current is passing, the flow of positive charges. So before finding electron, proton, neutron, so scientists were given the statement. So they given the statement is the flow of positive charges. Still you can observe. So in the textbook, the direction of the current will be taken from positive terminal to negative terminal. Positive terminal to negative terminal. So after finding electron, proton, they identified that. So the flow of electrons, because of the flow of electrons only the current will pass. So electrons will move from here. I will tell 2 points. So for MCQ's point of view, these points are very important. One is so proton, that is nothing but positive charge. Second one is electron. So that is nothing but negative charge. So here proton will move from high potential to low potential. So this positive cell has high potential, high potential. So in that cell, so it has high potential, and here the negative terminal has low potential. So positive charges, so very important MCQ's point of view. Definitely this question can be expected. So positive charges will move from high potential to low potential, whereas negative charges will move from low potential to high potential. Electron will move from low potential to high potential. So charges will, that is, positive charge will move from high potential to low potential. High potential to low potential. So that is about here you can see. So before finding electron proton, so they given the statement. So already they are using this one. Okay, so instead of changing the statement, instead of changing all the experiments, all the things, all the theory, we can change the simple definition. We can change the simple definition. That's the reason they changed the definition. So the flow of positive charges will be taken as conventional current. The flow of positive charges will be taken as conventional current, and the flow of electrons will be taken as electric current. So the flow of positive charges will be taken as conventional current. The flow of electrons will be taken as electric current. So that's why, so they consider these two. That's why they consider these two definitions. So these two definitions are very important. Make a note of it. Make a note of it. See here, hidden points are positive charges will move from high potential to low potential. High potential to low potential, whereas electron will move from low potential to high potential. Generally, anything, if you are taking temperature will move from a higher temperature region to lower temperature region. Even charges will move from higher temperature region to lower temperature region, higher potential to lower potential. But electron, you can see electron will move from low potential to high potential, low potential to high potential. So here is the this point can we can expect for exam and MCQ's point of view. Even these 2 points also expected, and conventional current and electric current, the flow of positive charges, and the direction. Here one more point, the direction of positive charges will be considered as a direction of conventional current. The direction of electric current is nothing but the direction of flow of electrons. So electron direction will be taken as a conventional electric current direction. So a flow of positive charges direction will be taken as conventional current direction. So there are many points, number of points we can take from this one concept. So we can take from this one concept like that. MCQ's point of view, it's very important. MCQ's point of view only, these points are very important. So that's why I'm saying, so make a note of it, note down. Okay, whatever I'm explaining, whatever I'm saying, note down. So prepare remaining time. If you have any doubts, you can ask. So I'll clarify your doubts. Okay. So this is about conventional current and electric current, and flow of positive charges, negative charges. So positive charges will move from high potential to low potential. So electron will move from low potential to high potential. And the electric circuit. So electric circuit definition is, so a closed and continuous path of an electric current. A closed and continuous path of an electric current. Electric current is known as electric circuit. A closed, see, it is a closed path and continuous path of an electric current. So current is moving continuously in a closed path. So it is not open path, right? So it is a closed path only, right? So that's why a closed and continuous path of an electric current is known as electric circuit. Electric circuit. So this is very important. See here, how many points came only from this concept? Yeah, so I hope nearly 10 points. So conventional current direction, conventional current definition, electric current definition, conventional current direction. Here also direction, and conventional current will be taken as flow of positive charges. Electric current is taken as flow of negative charges. There is nothing but electron. So positive charge will move from high potential to low potential. Electron will move from low potential to high potential. And the electric circuit is nothing but a continuous and closed path of an electric current is known as, so, electric circuit. Okay. So these are the points related to conventional current and electric current and electric circuit. So I hope it is clear to you all. So then shall I go to the next topic? So only 15 minutes left. So in this 15 minutes, I'll discuss two more topics. Then I will end today. So we'll go to the tomorrow class. Tomorrow 9 p.m. Surely you can join. Answara, are you there? So one girl, new student came. So whether she is writing or not. Shivani, are you understanding? Aishu is left, right? And Sweta, Tanishka, she didn't join today class, I hope. Shivani, is it clear? Yes, okay, done. So electrical potential and potential difference, I will explain. So electrical potential and potential difference. So very, very important concept, electrical potential and potential difference. So sometimes people will get confused the definition between electrical potential and potential difference. Even this concept is there in plus 2, plus electrical charges and fields. Electrical charges and fields, very, very important concept it is, electrical potential and potential difference. So I'm saying in a simple way. So those who are there in grade 12 also, you can listen to the class, potential difference. And those who are attempting, so JE mains and NEET also can join. So potential difference. Second one is electrical potential. Electrical potential. Sir, do you have smart board? Actually, right now it's not there. So I'm planning to install. So it will take time. Electrical potential. So soon I will work out on it. So meanwhile, I'm going with this electrical potential. Electrical potential. So potential difference and electrical potential. Is it class is okay? So are you understanding? Yes, you can give. Tell me. So I'll wait. Just okay, you can work out on it. So here I'm considering. Okay. So actually, okay. Anyway, today time is not there, right? So is it okay? So because I'm standing that side, so that's why it is falling light. Now if I stand this side, now it is clear. Now it is clear. Okay, done. Sure, I will work out on it. I'll work out on it. So I'm planning. Actually, in the previous videos, I did like that only. So still there is somewhere a problem. That's why I changed this view. So now still I can work out on it. So then it will go for better view. So here I'm considering the potential difference. Potential difference is nothing but so we are doing some work to bring unit positive charge from one point to another point. So potential difference is nothing but we are doing some work. We are doing some work to no, yeah. So I'll take it. I'll take so if it is for betterment, definitely I'll work out on it. Okay, surely I'll take it. Thank you so much. So for your advice, definitely I will consider and I'll consider. Definitely for the betterment of class, if anything is there, surely I will accept and take it. Okay. So thank you for advising. I am considering here because see, I can't able to get the clarity how it is viewing. So you people are listening the class, you people are no understanding so how it is appearing, right? So you must tell, then I can accept it. So accordingly I can work out. So if you have any doubts accordingly, then I am explaining, right? So like that only, this is also same thing. That is the reason I am asking. So I will take it, surely I'll take it and work out on it. Definitely I will make sure that so that lighting will, I'll work out on lighting. So this I'm thinking it's a better, like right now it's better. Still more clarity I will get it. Okay. So here I'm considering, I'm taking the work done to bring unit positive charge from point A to point B. We are doing some work to bring the positive charge from point A to point B. So within the conductor, if the work is done, that is called potential difference. SI unit of potential difference is volt. SI unit of potential difference is volt. SI unit of work is joule. SI unit of work is joule. And SI unit of charge is coulomb. SI unit of charge is coulomb. Okay, so SI unit of potential difference is volt, SI unit of work is joule, SI unit of charge is coulomb. So these are very, very important for MCQ's point of view. Make sure that you are noting down all these points. So within the conductor, if work is done, that is called potential difference. So I am taking this the one field, this is the field. So charge is there at infinity point. So I'm taking this is the charge, so it is at infinity point. So positive charge. We are doing some work. We are doing some work to bring this positive charge to the field. So this is the required field. So this is the required field I am taking. So we are doing some work to bring the positive charge from infinity to the required field. Infinity to the required field. That is nothing but electrical potential. So same formula we will use. V equal to W by Q. So V equal to W by Q. Same formula will use. V equal to W by Q. Same formula will use. So potential difference, work done and charge. Work done and charge. Sir, hi. Hey, made a what? What is your name here? So you said some name. Hi, now you joined. So very good. Can you tell your name? Okay. Daniel. So you are using different accounts. Okay, done. So come to the point. So now we can see electrical potential, electrical potential. Okay, okay. So you are following one account, no? So to that number, to that account only I'm removing. I'm following. Okay, done. Come to the point. Thank you so much. So here you can see V equal to W by Q, V equal to W by Q, SI unit of work is joule, SI unit of charge is coulomb, SI unit of potential difference is volt. And here you can see so electrical potential also same thing. Potential difference and electrical potential also same thing, right? So do you have any doubts in this topic? Do you have any doubts? If you have any doubts, you can ask me. So still I can go to the next topic. So this is about potential difference and electrical potential. Now here one more example is there. One more example is there. Actually that example we can work out on better way. So I will explain here. So I'm taking the two beakers like this. So I'm taking the two beakers. So two beakers are placed at same height. I'm taking same height. So here water is there, water is filled until the same level, water is filled, until same level water is filled. So if you connect these two beakers, will the water will flow from one beaker to another beaker? No. So water will not flow from one beaker to another beaker, because so same height, same level, so there is no difference. So here if you are considering one beaker at certain height, another beaker I am taking, so both the beakers at certain difference, some certain height is there like this, and here also certain height. So water is filled in this beaker, and here also water is filled in this beaker. So if you take, so if you are connecting this one, if you are connecting like this, what happens? Water will flow from okay, so beaker A to beaker B, water will flow from beaker A to beaker B. So how it will flow? Because of some difference is there, some height difference is there, some pressure difference is there. That's why water is flowing from Aish, very good. So join to the class. So many interesting topics are went. So you can go to the live class again. So back to the live class, and you can learn. So many important points I discussed in the class. Very good. So here you can see. So because of some height difference, so the water is flowing from point beaker A to beaker B, So here also, if you are considering the conductor, so in the conductor, so electrons will not move without any difference. So here to here same only, right? So same pressure is there, same difference, same. So no difference from point A to point B. So if it is connected battery, so here high potential will be created, here low potential will be there. Then electrons will move, or charges will move from high potential to low potential, as we discussed about conventional current. So charges will move, positive charges will move from high potential to low potential, whereas electrons will move from low potential to high potential. So that is nothing but electric current and conventional current. So this is about potential difference and electrical potential. Very, 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 so many. So into infinity times you multiply, that much important this concept. So potential difference and electrical potential, including formula, V equal to W by Q, V is the potential difference, SI unit of potential difference is volt, W is the work done, SI unit is joule. So SI unit of charge is coulomb, 1 volt equal to, so SI unit also they will ask, 1 volt equal to 1 joule of work is done to bring 1 coulomb of charge from one point to another point. So that is a SI unit of potential difference. So they will ask, define SI unit of potential difference. Define SI unit of potential difference. So if they ask define SI unit of potential difference, so 1 volt equal to 1 joule per 1 coulomb. 1 volt equal to 1 joule per 1 coulomb. So very, very important. So point on the potential difference and the electrical potential. So we discussed many points. See, if you are taking one concept, if you go in depth of the topic, definitely see marks automatically you'll get. Marks are the byproducts of concept. If you know the concept, definitely automatically you'll get marks. So no doubt at all. Okay. So I am saying, so this concept is very, very important. So learn from it. Learn concept. 1 volt equal to 1 joule per 1 coulomb. Next one, resistors are connected in series and resistors are connected in parallel combination. We'll discuss. So I hope now nearly 10 o'clock. So we'll discuss this concept. Give a reminder. So tomorrow problems we'll discuss related to this one. Or after completion of that, if you want, we will discuss the problems. So anything is okay. So either problems on these topics, or we'll work out on at the end we will work out on problems. So that is very important. First get the concept. So we'll work out on problems. So problems, it will take time. If I take one problem, So throughout the class, we will do this one problem only. So time won't be sufficient. So tomorrow class, I will continue. The resistors are in series, resistors are in parallel. If you like this content, if you like this video, so please do like, share and subscribe to Student in the Brand. This is your Siva sir from Student in the Brand. So thank you so much. So all are those who are there, Sivani, Ayush, Daniel and Answara and Anhad and Abel. So everyone, so just join to the class tomorrow at 9 p.m. and inform to your friends, inform to the friends, ask them to join. So you can get the concept. If they have any doubts also, you ask them to join and ask. So even if you have any doubts also, you can ask. So win-win situation, you can get the concept, your friends also get the concept. So it's like a pro. Okay, so from a pro, you'll get the concept in a better way. So try to involve in the class. Try to involve. My request is only one thing. So spending your valuable time by attending the class. Definitely, I will satisfy. No, I will do my level best to give the better content, best content from my end. From my end, definitely I will provide. I'll provide the content. Okay. So even if you have any doubts, also you can ask. You can post in the comment section. I will answer it. Even if I'm unable to answer at that moment, definitely next day or after that also, if you give a reminder, definitely I'll work out. Okay, I will answer to those questions. Okay, so this is the content from my end. Okay, so try to practice from day one onwards. My request is, so instead of joining and listening, so try to practice along with me. Take the book, take the pen. So I will give time to write also. If you ask any doubts also, I'll explain. So 9 o'clock class, definitely I will work out. See, if you are attending the class, from my end, I am telling one thing. If you are attending the class, this class, definitely CBSE grade 10 physics very easy to you. So if you practice along with me, including problems, along with the concept plus problems. So try to join and work out with me, practice with me. Okay, ask doubts, ask many doubts, try to ask doubts. Then I can understand you are listening and involving and learning and doing good. So until namaste, thank you so much. See you soon in the next class tomorrow 9 p.m. Thank you.